collisions. Let us understand about. Yeah, so collision, right? So let's say I have. So let us start. Right, and before we start, we have to remember that what have we studied, right, in the previous classes. So first we remember that nature acts in a peculiar way, right? Whatever is going into the system, that will come out of the system, right? Whatever transformation, whatever thing is going on, so it will be replicated, right? So let's say, and whatever energy is going in a reaction, that will come out of that reaction, right? So first balancing thing is that the energy, total energy would be conserved, right? This thing we have to keep in mind. And the second thing is that linear momentum is conserved, right? So nature is very balanced, right? This is how the nature works. So whatever thing is disturbing the system, the total output will be the same. So that will go into this collision, right? So let's say we have two particles, two objects, right? We have this one and this one. And usually in
Sir, do you have to write it down?
no. So I will give you the time to put it down, right?
Okay, sir.
So yeah, so okay, so there are two kinds of collision that we will understand in this class, right? There are two kinds of collision that we will understand, and one would be the elastic collision, right? And remember, this is totally different from whatever you have learned in your second book, first chapter, right? This is not related with that elasticity, plasticity. This elastic is different, right? Only the names are similar, but this talks about collision, that talks about the properties of the solids, right? Those two are different and yeah, this one, and then we will have inelastic collision, right? So inelastic collision is also two kinds. One is perfectly inelastic collision, and then the other one is simply the inelastic. So perfectly inelastic, we can. So these are the different kinds of collision that we will understand. This one is whenever the word head on is given, right? Whenever the word head on collision is given, so we will consider it to be elastic collision, right? So these are the kinds of collision that we will understand. And in all of these collision, these two would be there. These two would be always there. because this comes from the nature itself, right? So, and in the elastic collision, third property would be added, and that would be that kinetic energy is also conserved, right? And this inelastic collision, right? Inelastic collision, the third property would be that kinetic energy is not conserved, right? So let's say two objects are colliding with each other, and some energy is dissipated, right? Let's say this object is there, and this comes, and then they collide, right? And all of the momentum, right? Whatever the momentum of this object was, that is not transferred in this one. So some is gone into kinetic energy, right? And some energy is dissipated. So this kind of collision is called inelastic collision, because total kinetic energy has not been given to these two objects, right? So some kinetic energy has gone to some other means, and maybe this can be heat or any other energy, right? So these kind of collision are called inelastic collision. So first, let us understand about elastic collision, right? And this thing would be very crucial in numericals. So this is very crucial. So let's say we have an object, right? And let's say this is B, and we have another object which is coming at this object, right? A, with u1 velocity. This has u1 velocity, mass is m1. This has mass m2, and this is at rest. So then they collide, right? Then they collide, and this one, let's say this one goes with this one goes with v1 velocity, and this one goes with v2 velocity, right? So these are the two different velocities of the final the after collision scenario. So this is after collision. This is before collision, and this is at collision. So there are three different phases, right? So the first thing that we define is the coefficient of restitution. So right, this one is very important quantity. So first thing that we define is coefficient of restitution, and this is defined by E, and this is given by velocity of separation, and this should be relative velocity of separation, and relative velocity of approach, right? So this is relative velocity is v1 minus v2. I should write v2 minus v1, right? And this is u1 minus u. So this is the coefficient of restitution. And this quantity is very important to determine what kind of collision. So if you have this E equals to 1, then this is called elastic collision. So whenever you have this E equals to 1, that is elastic collision. And then we have to determine what is V1 and what is V2, right? So these are the two things that we have to determine. And you see that how many unknowns do we have? How many unknowns do we have? Yes, how many unknowns do we have, Siddhika? Okay, so let's say that you already know, right? You already know that there are two velocities, u1, u2. Their masses you already know, right? So what are the known things? Let me write the known things or parameters. They are M1, M2, U1, and U. So these are known parameters that you already have. And then you have unknown parameters. Unknown parameters V1, V2. So these are the two things that you have to find out, right? For as of now, we are not considering this theta 1 and theta 2. As of now, we are not bothered about that. Right? This we will think about later. So these are the unknown parameters that you have. Okay. So now, yeah, so these are happening in two dimensions, right? As for now, you consider that this theta 1 and this theta 2, they are zero, right? So this is happening in one dimension, right? Right, it in one dimension. As for now, we'll talk about one dimension and then we will talk about two dimension. So let's say this is V1 and the other one is V2, right? So all these are in one dimension. Okay, so you have to find out V1 and V2. And what do you know? First thing you know is the conservation of momentum. Conservation of momentum. Because this is the elastic collision. So you have initial momentum, right? You have this object, you have this object. This is 0, this is u1, right? This has mass m1, this has mass m2. And then final is u1 with v1, m1 with v1, and then m2 with v2. So you have v1 velocity, v2 velocity. So what can you tell about the momentum of this thing? What is the momentum? What is the momentum of this thing? Yes. What is the momentum of this thing? Yeah, what is the momentum, Siddhika? Do you remember what is momentum? Momentum is product of mass and velocity, right? This is the momentum. So if we write the momentum of this thing, so that would be m1 u1. Momentum of this thing would be m2 u2. So this is initial momentum, right? And that would be equal to final momentum. So conservation of momentum is what? Initial momentum, that would be equal to final momentum, right? So this is this would be equal to m1 v1 and m2. So this is the final, right? And I'm not writing in this vector form, right? So if I write this in vector form, then that would be a different scenario. So this is the first conservation of momentum. And we know that this u2 is 0, so that we can cancel. And we will get m1 u1. That would be m1 v1 plus m2. This is the first thing that we get, right? And then we also know the conservation of kinetic energy, right? So from conservation of kinetic energy, what we can say that kinetic energy initial, that would be equal to kinetic energy final, right? So kinetic energy initial, what is the kinetic energy of, let's say this is mass m and velocity v. So what is the kinetic energy? Satika, text. Yes. Okay, Siddhika, what would be the kinetic energy? Uh, so kinetic energy, you have forgotten.
The formula,
Yeah, yeah. So that is,
1 by 2 mv square.
yeah, so absolutely correct. So why you were not telling me this answer? So kinetic energy is
Okay.
half mv square, right? So now we have to write the kinetic energy of all these uh, all these masses, right? So what do we have? We have this mass m1 moving with u1. We have the another mass m1 and this has stationary, right? And then it goes to after collision scenario. This goes to m1 with v1 velocity and then m2 with v2 velocity, right? So if we write the kinetic energy of all these things, so half m1 u1 square plus half m2 square, that would be equal to half m1 v1 square and half m2 v2 square, right? So we know that u2 is 0, so that part is gone. And we have half m1 u1 square and half m1 v1 square and half m2 v2 square. So this half, we can take a common and we can cancel. So what do we have? We have m1 u1 square, and then we have m1 v1 square plus m2 v2 square. So what we can do is that we can take this thing, right? We can take this thing in the left hand side. So m1 u1 square minus m1 v1 square, that is m2 v2 square. And we know that m1 we can take common. This is u1 square minus v1 square and m2 v2 square. So this is the identity. We can write this as u1 plus v1 and u1 minus v1. This is m2 v2 square. And if we look back at this thing, right? So if we look back at this thing, so we can write here. Let us keep this thing like this one, and from equation, right? What was equation one? That was m1 u1 and m1 v1 plus m2 v2. So if we take this thing quantity in this side, so m1 u1 minus m1 v1, this is m2 v2. So if we take m1 common and this is u1 minus v1, m2 v2. So let's say this is the third equation. So if we look at the third equation, m1 u1 minus v1, m1 u1 minus v1, that value we have got, right? Right, Siddhika? So this value we have got. So if we put this value in equation second, so what we will get? Right. So in by putting the value in equation two, that would be how much? That would be q1 plus v1 and then m2 v2. And this is what? This is m2 v2 square, m2 v2 square. So m2 cancel, v2 and 1 v2 cancel. So v2 is how much? V2 is U1 plus V1, right? This is V2 equals to U1 plus V1. This is the relation that we got. And now if we put this value in this thing, or let's say in here, right? Then we will get the value of V1 and subsequently we will calculate the value of V2. So I guess this derivation you have already done in your CBSE part, but I am just revising that part, right? So you put the value of V2 in equation 1 that you got, right? So putting the value of V2 in equation first. So what was equation first? M1 U1, M1 V1 plus M2 V2. So this V2 we will put back. So M2 and U1 plus V1. This would be how much? So M1 U1 and M1 V1 plus, oh, this is, so M2 U1 and this is M2 V1. So M1 U1, this thing goes in the left hand side and M2 U1, this is equal to M1. V1 we can take common, right? And again, u1 we can take common. So m1 minus m2. And what was the unknown parameter that we wanted to calculate? V1 was the unknown parameter. So V1 would be M1 minus M2 divided by M1 plus M2, right? And U1. So this is the most crucial thing, right? This is the first thing that we got. And from this equation, fourth one, we can calculate V2. So V2 is U1 plus V1. So U1 plus, let me write it as M1 minus M2 U1 divided by M1 plus M2. So if we take the LCM, this is M1 plus M2, and this goes in here U1 M1 plus M2 plus M1 U1 minus M2. This would be how much? M1 U1 plus U1 M2 plus M1 U1 minus M2. M2 U1, M2 U1, this will cancel and you will get what? So V2 would be M1 U1, M1 U1. So 2 M1 U1 divided by M1 plus M2. This is the another unknown that you wanted to calculate, right? So this would be the second one. So this is V1 and this is V2. So always remember this, right? In the plane, whenever we have one dimension, right? So elastic collision in one dimension, then always remember this, right? So this part is not needed. You please start noting down from here. Okay. Do you have any question?
Okay, sir. No, sir.
Yeah. So
I
this was a
understood.
lengthy. Yeah, this was the lengthy. This part you have already done in your CBC. So
Yes, sir.
maybe I should have directly wrote that part, but yeah, I wanted to. Why? This is elastic collision in one dimension.
Okay, sir.
Yeah, whenever you want me to scroll down, please tell. Yeah, whenever you want me to scroll down the screen, please.
1 second, sir. Sir, could you scroll?
Uh, Okay, so what I said earlier, yeah, in this part, that coefficient of restitution, that would be 1 for elastic collision, right? And yeah, I will, so that we'll talk about again in the end, that we solved all these things for elastic collision, right? And in the end, did we get this 3 equals to 1? That, okay.
Sir, could you scroll?
Yes. Yeah. So always remember in this collision thing, we have to remember that The unknowns are the final velocity, right? So two objects are coming, they are colliding, and then whatever the speed which with they are going, these are the two unknowns, right? So that is the final goal that we have to calculate.
Sir, could you scroll?
Yes. Good.
Sir, could you scroll?
Yeah, quickly note it down so that we can do some questions, right?
Yes, sir.
And the only thing that you have to remember in all these things that these are the two velocities. So this is the only takeaway that we should take from long definition. Yeah, whenever you have completed, please.
Sir, done.
Yeah. Okay, so what I was telling you that the coefficient of restitution, that is 1 for the elastic case, right? So if we look at this equation, right? If we look at this equation 4, so from equation 4, what do we see? We see that V2 is U1 plus V1. So if we calculate V2 minus V1, that is U1, right? And if we write the coefficient of restitution, that was V2 minus V1 divided by U1 minus U2. And in our case, U2 was 0. So this was what? This was V2 minus V1 by U1. So in here, if we calculate V2 minus V1, so that is what? U1, right? So this is a U1 divided by U1, so what we will get? 1. So that is how we say that the coefficient of restitution for the case of elastic collision, that is 1. So always remember this, right? Okay, and second part is this is very important in vector form, right? In vector form, we can also write the elastic collision. So elastic collision in vector form, and that is applicable to every dimension, one dimension, two dimension, right? So in vector form, elastic collision, first equation will give you P vector initial, that would be P final, right? Second one would be kinetic energy, because kinetic energy is not a vector quantity, it is a scalar quantity. So this doesn't affect much. But This is very important, right? You please, yeah. So then we can do one question to understand. So let us do one question and then that. So whenever vectors are given, we have to use this vector form. Okay. So an object flying in air with velocity suddenly breaks into pieces whose masses are in the ratio. The smaller mass is this with velocity and the velocity of larger mass will be, right? So this is related to conservation of linear momentum, right? That is what we have to understand. So we have this object, right? This object which was moving with, let's say, this v velocity, right? Let's say u velocity. With u velocity, it was moving, and we have to write vector, right? Because this is vector. And then it breaks apart, right? At certain stage, it breaks apart and moves with different velocities, right? So one has uh, one has the smaller mass flies with this velocity, the velocity of the larger piece. So let's say this is the larger piece, and its velocity is v2. The smaller one has a velocity v1, right? Now you see that the masses divide in 1 is to 5 ratio, right? So let's say if I consider the ratio, let the ratio, let's say the ratio m, right? So this would be 1m and this would be 5m, right? The bigger one is 5m and a smaller one is 1m. Is this clear? Is this clear?
Yes, sir.
So,
Yes, sir.
or we can also consider that let's say the one bigger was 6 and it was divided in, let's say it is 6 mass. It is divided in 1 mass and it is divided in 5 mass. We can also understand it this way. So total mass is 6m, right? So total mass or initial mass is 6m. This is a smaller one is 1m, bigger one is 5m. Now we have to write conservation of momentum in vector form. Conservation of momentum in vector form. So we know that P initial that would be equal to P final, right? So what is the momentum of this thing? What is the momentum of this thing? What is the momentum, Siddhika? Remember, momentum is product of mass and velocity. What is mass? 6. Velocity is u, right? So this is 6m and velocity is u vector. Similarly, this one has mass 1m, velocity v1, and this one has mass 5m, velocity v2. So this is the relation that we have. And what are the known things that you know? The known things, the smaller mass flies with this velocity. So you know that uh, what is this u, right? Which is this velocity, 20I plus 25j minus 12k. And you also know this v1 velocity, which is 100I plus 35j plus 8k. And you have to figure out this thing, right? So we put all the values in here. We put all the values in here. So this would be, and you know that m. So this will cancel, right? We can take it common, and this will cancel out from every term. So 6 and u is 20I, 25j minus 12k, and this is equal to v1 100I plus 35j plus 8k plus 5. So how much is this thing? This is 120I, and this is how much? 150j and 72k, and this is 100I, 35j, 8k plus 5 v2. This is, if we take this thing this side, so 120I plus 150j minus 72k minus 100I minus 35j minus 8k. This would be how much? 120 minus 100, so that is 20I. And then 150 minus 35, so that is 115g, right? And then minus of 72 and 8, so 80k, and that is 5 v2. So if we calculate v2, that would be 20I plus 115j minus 80k divided by 5. So this is 4I, and this is how much? 2 and 3j and 16k. So we have yeah, so 4I plus 23j, right? And why we are getting this 72, right? And this is 8k, 12 and 6 ton, and this is 8. This minus 8, right? So there must be something wrong in here. 72 minus 8k. So that is 80. So that should be 16, right? So in here, the option is incorrect, and that should be 60. Velocity of the larger piece. That should be. So you please note it down, and if you have any doubt, please tell. This should be the velocity. Is it clear, Siddhika? Is it
Yes,
clear?
sir. Yes,
Yeah.
sir.
Then please note it down. And I can also check whether 135 8 give you answer. 20, 25 minus 12. 20, 25 minus 72, right? 22 minus 8, that is 80. 80 divided by 5 is 16. There is wrong in this question. Why? There? Yeah, you please note it down, and whenever you want me to scroll down, please tell me. Text. Yeah, whenever you have noted it down,
Done, sir.
then okay. So all these parts you have noted it down. Yeah. Have you completed this one also? Yeah. Whenever you have completed, please tell.
Done, sir.
Okay. So now let us do another question, right? And that is also on the vector forms. In some cases, we have to use a vector form. Whenever the vectors, yeah, whenever, yes, let's say the 50-second equation, that one we can do without a vector path. But in this one, we will need again vectors, right?
Sir, I
Yes.
actually don't have battery.
Oh,
I'm only on 6%.
oh yeah.
Uh,
So okay. So then let us do a question of the caliber of 6%, right? How many? So okay, how much time do we have? 6%, meaning how much time it will take to deplete that 6% time? Or we can, yeah, we can end this class now.
yes, sir.
Okay, yeah, so we will end this class now, and the next class we'll only do these questions quickly, and then we'll start the new chapter.
Okay, sir. Thank you,
Okay,
sir.
Allah Hafiz, Siddiqa.
Allah Hafiz.
Assalamu alaikum.